All right, Mr. Ahmed here, working on chapter 10 again, 10.3 today. Our goal is to use chords. Our chords, keep in mind, brief recall on the definition. A chord is a segment whose endpoints are on the circle. When we say on the circle, that means it's the edge, okay? So a chord would look something like this. Endpoints on the circle. Okay? The chord facts. Theorems. There are some things that go on with our chords. Chords that are congruent in length inside the same circle. So in this case, we have the circle L. And if chord FG is congruent to chord JH, then their arcs are also congruent. So arc FG is congruent to arc JH. That is what we know. And that also works the other direction. If these two arcs are congruent, then the two chords would also have to be congruent inside that same circle. Okay, so lots of things that are equal here with our circles. Next thing, congruent chords are equidistant from the center. The distance always has to be at a perpendicular right angle. So when we talk about the distance, the shortest distance from the center to this chord is at a right angle. And if these two chords are congruent, chord FG congruent to chord JH, if that's the case, then the distance L to Y has to be congruent to the distance LX. And those have to be marked at right angles, the shortest distance to that chord. All right? And the third theorem slash fact is that a diameter is perpendicular to a chord. If that's the case, if the diameter is perpendicular to a chord, then it bisects both the chord and its arc. So that means if AB is perpendicular to XY, if that's the case, then we would know XZ is congruent to ZY. So it cuts the chord in half, and it also cuts the arc in half. So arc XB would be congruent to arc BY. So the diameter, if it's perpendicular to the chord, if the diameter is perpendicular to the chord, then it cuts the chord in half, and it also cuts the arc in half. So XZ, the chord's cut in half, ZY, and the arc is cut in half. All right? It's pretty obvious when you look at the picture. Okay, we're not going to try and trick you on these too much. Next step, hopping into some examples. So, our first case says, find X. So when I look at this, I see that arc AB is congruent to arc BC. They're both 109 degrees. If that's the case, if these arcs are congruent, then these two chords are congruent. So we just need to say that 3x plus 2 is equal to 5x minus 7. Kind of looks fairly obvious, all right? Then we just solve. Let's see here. We will subtract 3x from both sides and get 2x, and then I'm going to add 7 equals 9, divide by 2, and x is equal to 9 over 2, or also 4.5. I don't care which one we use. Either one is correct. Next one. Again, I see congruent chords. If the chords are congruent, then so are their intercepted arcs. So arc KL is congruent to arc JK. Now KL is X, so that means JK is also X. When I take a look, that takes up the whole circle. So X plus 70 is equal to 360. When I solve, 2x plus 70 equals 360. 2x equals 290, and x is equal to 145. Okay? Next one. We have a radius, and it's 14. So if I think about this, I see the radius. That would also include this whole diameter. It's perpendicular to the chord. If the radius is perpendicular to the chord, then it cuts the chord in half, and it also cuts the arc in half. So let's see what we know. CD is 22, so C to D, 22. That means each little part is 11, okay? It says CB is 27 degrees. If this piece is 27, DB also has to be 27. It cut the chord in half, cut the arc in half. So what were we supposed to find? CE is equal to 11. Already labeled it. BD, 27. I should say the measure of arc BD is equal to 27 degrees. And lastly, DCB. D to C to B. So for us to find DCB, I would have to take 360 minus 27. So DCB is equal to 360, the whole circle. DCB, take away the missing part, 27. And that is 333 degrees. Okay? And moving onward to our next problem. We have our circle, circle E. What are we looking at here? It says HQ is 48. So let's see, where's HQ? Measure of our HQ, 48 degree sign. So let's see what we know about that. Radius is perpendicular to the chord, so that means it cuts the chord in half. That means QI also has to be 48 degrees. All right, next thing that I know, HI is equal to JK. HI, JK, those are congruent chords. So if these two chords are congruent, that means their arcs are congruent. So that would have to mean that JS is also 48 and KS is 48 because this chord was also perpendicular to the radius. So it is cut in half. All right, let's fill in what we know. HI, 48 plus 48. 48 plus 48 is 96. Got it. Next step, QI, we already labeled it, 48. JK, arc JK, same thing. Those two arcs were congruent because the chords were congruent. So that means these segments all have the same length. So it's also 96. And HI, well, we haven't done that part yet. JR is 7.5. So that means each one of these little pieces is 7.5 because they're all the same length. So let's see. HI, 7.5 plus 7.5 is 15. Got it. PI, where's P to I? Oh, P to I, 7.5. And J to K, 7.5 plus 7.5 is 15. Got them all. Now, as you're working on these, you got to kind of put all of these theorems and facts together in order to find the missing parts. A lot of things are equal. All right, so wrapping up for today, number 5. I want to take a look. The problem says that the radius of circle O is 32. Now, I do not see a radius in, so I'm going to have to come back to that. The next step says arc PQ is congruent to arc RS. So the two arcs are congruent. If the two arcs are congruent, that means that their chords are congruent. So PQ and RS are the same length. We also know that PQ is 56. So from P to Q, 56. Now, this segment here goes through the center, so it is a radius, and it is perpendicular to the chord. Therefore, the chord is cut in half. So if the entire thing is 56, for me to find PB, I would take 56 over 2, which is 28. So I found PB to be 28. That means BQ is also 28. RA is 28 and AS is also 28. Reasoning, these two chords are the same length. So all of their parts, it's also cut in half. Next part says to find BQ. Well, B to Q, we already said is 28. O to B, that's a little trickier. We're going to come back. RS. RS, 28 plus 28 is 56. It was the same length as PQ. Now to find OB, when I look at this diagram, for me to find OB, I'm going to need to make a right triangle. So for me to make the right triangle, I'm going to connect O and Q. I could also connect O and P. Doesn't really matter. When I do that, I was told that the radius is 32. The radius goes from the center to the edge, so that means this is 32. Now for me to find OB, I will find X using Pythagorean's theorem. So the hypotenuse is 32. 32 squared equals X squared plus 28 squared. When I solve this out, I get 1024 equals X squared plus 784. Subtract from both sides and I get 240 is equal to X squared. Take the square root, and that is equal to 4 times the square root of 15 if you simplify the radical, or about 15.49. Either option is correct, and we are good to go. Have a good rest of the day.